we are talking about welding assembly representation and rivets spline connections. Okay, so how to represent them in the drawings, how to correctly understand, how to define, and have to see this, what kind of the size, what's the technology, what's the way of making a welding assemblies. So today is the last lesson on this subject. As an introduction, I'd like to show two things. There's two things. The first one is the fastening with bolts, screws, and rivets to create a kind of temporary joints. Okay, so temporary joints. So you can unscrew it, the bolts and screws and rivets, or you can remove the rivets, and then you can replace the part with new one. Okay, so we call this one is just temporary joint. Okay, so how to okay, when we use this one, when we have thin plates to join, we need to, okay, two plates are given, so we can use we fasten with a bolt or screws and rivets. Okay, and also the good point of this type of the joint, making a joint, is we can make a joint non-metallic parts also. And so for the temporary parts, like temporary elements also can be joined with this one. And in case of the need of changing inside thing or another part, so we can open that kind of a door. Okay, so temporary part, and then replace the part inside, and then screw it again. Okay, and removable parts. Sometimes we need to remove in some kind of technological issue might happen. So in that case, in the building, in the construction, in kind of wheel. Okay, so vehicle. So we need to open inside and change or exploit some purpose, like change or make a some operation inside it and close with using screws. Okay, so this one is a temporary joint. And second type is making a joint, is welding. Okay, in this case we are making a, like, okay, so formed by casting or forging. Okay, and things, okay, so the parts is made by casting or forging, can be welded, like metallic parts. Structural steel frames for buildings can be created by welding. And for the ships, the part of the ships, big things, also can be welded. That's very cheap joint, and but that one is permanent, kind of permanent welding. And some kind of welding is possible, like you can do in underwater. Okay, and in cold weather also, it can be done with this type of the joint. The another type of the joint is the gluing. Okay, so we are not study this one. So gluing, joined with using a glue. Okay, so this is the common thing is for joining non-metallic parts. Okay, so non-metallic parts, and that is expensive joint. So that's why we are not learning this one. It's not widely used. It's used in aerospace, and it's used in composite material, using industries. Okay, so okay, so the next. So today we'll study about welding. Okay, so welding. So how to represent them, how to draw them. Okay, so before understanding the drawing and defining the uh, definitions. Okay, so right, drawing the definitions of the welding, we need to understand the welding process itself. So there are types of the welding. The first type is the gas welding. We call gas welding. Okay, so we use for gas welding oxyacetylene method. Okay, so we call oxyacetylene method also is originated in 1895 by French chemist Le Chatelier. and he combust. Okay, so he discovered that the combustion of two things, okay, so acetylene gas with oxygen can produce a flame um, for melting the metal. Okay, so he understand that the produced flame can create enough temperature to melt the metal. Okay, so we are using gases. Okay, so acetylene and oxygen. Okay, so second thing is arc welding. So for this purpose, we're using mostly in electricity to create an arc. Okay, so the heat and electric arc is used to fuse the metals that are to be welded or cutting. Also, you can cut it. So there are types, a lot of types of the arc welding. So gas metal arc welding and metal inert gas welding. So during the welding, they're using some kind of environment, gas environment. Okay, inert gas welding, metal active gas welding, gas tungsten arc welding. So for this types, we're using this kind of abbreviations in the drawings. Okay? So that's why I draw here. So if you see this kind of abbreviations, so that means the type of the welding. And the third type is resistance welding. So also is we are using electric resistance, okay, for to join two pieces. Okay, so two pieces of metal are held together under some pressure. So we are using a pressure also, and a large amount of electric current is passed through the parts, heating at the junction, so the joining place of the two pieces, resulting in the welding of the metals. Okay, so we're using a pressure, and also we're using a kind of resistance of the joining parts. Okay, so in this slide is given welding features, so how to represent them in the drawing, but how to understand what kind of terminology are used for in the drawing to describe in the drawing in the inside the drawing. Okay, so those are can be a type of the weld, as I told you that type of the weld in before the videos are described in the previous videos. So for this one there is an abbreviation. Okay, so you can show, so I will show how to represent this one in next slides, and the process also can be added there. The depths of weldment. Okay, so so here you can see that the depth is shown here. So two metal plates are given, the plate 1 and plate 2. So to join them, we are making kind of two weldments here. So first one, okay, this area, so depths, okay, depths of penetration of filament, the size is this. So this one we can show, and groove weld size. Okay, so the sizes, like the length of the weld, okay, this and that, and groove angle, so angle is this one, okay, and the length of weld is here, this. So these three things are related to groove weld size. Okay, so groove angle, length of the weld, and root opening. Root opening is here. So before welding, we are putting two pleats like this. Okay, or say if this one is groove weld, so something like this pleat. So this distance is root opening, called root opening. Okay, so these sizes can be shown inside the drawing and can define a welding definition. Okay, there are 5 types of the welded joints can be done. Okay, so the classification. Okay, so they are classified according to the position of the part being joined. The first type is we call butt joint. So the first plate is here, second plate is here. Okay, so the send side, okay, so should be touched to another pleat send side, and we call butt join. Okay, so if you put some kind of first plate here and second plate in the corner to the bottom, we call corner joint. And the first plate is here and second plate is like this. If you put like T shape like that, or opposite way like this, we call T joint. The lap joint, if you're put the first plate like this and second plate on the bottom, and the welding place is shown in the gray color, that's called lap joint. Okay, and if you join the white sides of the pleats, the first pleat and second pleat like this way, so gray area is should be joined together, so that calls edge joint. Okay, so in next slides can show how it looks like in reality and how it looks like the symbolic representation. um, um, why we are learning this one, because in the drawing we never draw this like in reality like this. Okay, so we are simplifying in the drawing and showing symbols with symbols. Okay, so that's why we need to understand how it should be in reality, how it should be welded. And arc and gas weld symbols are similar, okay, as follows. Okay, so illustration or reality is like this, and in symbolic thing is this. Okay, so we're drawing this kind of bump shape, and then the down part is straight line. That calls backing. Okay, so back or backing. So this kind of join. Okay, so butt joint. And T shape or fillet kind of the joint, so like this. So we are drawing this kind of triangle. Okay, so and the plug or slot like this, if you have like this rectangular shape, so we need to draw this kind of rectangle shape. Okay, so the groove weld symbols, so it might be, so here you can see that the pleats are parallelly shown here. So for this one we are using a symbol like parallelness symbol. And if you have this kind of V shape, so we draw this kind of V shape in the drawing. It calls V type. Bevel type, so one side is straight, one side is like this with slope. Okay, so bevel shape. And this one is U shape, and this one is J shape, so straight and like this. So only one plate is straight and another side is like this bumpy. So the all are as groove symbols. And on top of this, we're using supplementary symbols to show how to weld it. So if you have this kind of symbol on your drawing, an arrow, and then the straight line, and here the circle, that means weld all around. For example, in the drawing, you have some shape, and then so if it's shown with an arrow, the straight line, and like this, so that means all around this rectangle should be welded. So all this red line, through this red line you have to weld. Okay, so the meaning of this. And if you have this kind of symbol with flag, so flag is shown here, like, okay, so triangle flag, that means field weld. So you are doing your assembly, or your welding assembly in the field. Okay, so outside somewhere you have to bring all the parts there, and you have to install some part of the assembly, and then you need to add by welding and in the field. Okay, so field weld. So that's why there is a flag. So it's windy area, kind of, to show the windy and outside. if you have this kind of symbol, that means you need to melt through. Okay, so if there are two pleats are given, so one pleat, second pleat, so when you weld it here, so you need to melt it. You have to keep a little bit more time your weldment here. Okay, so you need to melt it through and then weld it. Okay, so that's why it's shown like this, the pool of molten metal here. Okay, and if you have rectangle, okay, square shape on top of this straight line, that means consumable insert. That means your weldment should be very nice, very healthy thing, or we need to well use this one for consuming by human. Okay, so kind of the liquid tank, or some volume for um, keeping the water, or some kind of liquid for consuming. Okay, so consumable some tool for using like human consumption. Okay, so for this purpose you need to add this kind of symbol. Okay, this symbol. And there is a backing or spacer material, like you can write it here, your material inside. And there are two types of the contour showing. So flashing, just flashing, you need to draw like straight line. If the convex is like this, if the weldment, because a welded area, if you see, okay, so two plates, like the one plate is here like this, so another plate is here like this shown. And if you welded line is like this, so that is convex. If the welded area is like this, so it's concave. If you have flashing, okay, so the flashing I will show in next slides. Okay, so it should be straight, right? So symbols, again, this type, fillet type. Okay, so fillet type welding symbols can be shown like this. So one side shown with this one, this is in reality, and this is in the drawing is shown with triangle. So if another side is shown, you have to weld another side of the T-joint. If it's shown in the both sides triangle, so you need to weld both sides. Okay, so why we are learning this? Because if you will become an engineer, you need to add those requirements, and operator, based on your drawing, will weld in or assembly the part. Okay, so another thing is, okay, so here there is a shown by third angle projection method, front view and top view here, and that is a this right hand side view. That's American style. So that's why shown like this, only one side, so that side should be welded. Okay, that is another side, that's arrow side. Okay, so another symbol we have, this one. This symbol represents also welding, so that is simple welding, simple one, simple welding symbol. But this one is more complex one, and more you can show more information on it. Okay, so this kind of symbol. So here the one arrow and two ends there. Okay, so you can draw here, you can show here a lot of values about welding. So on next slide you can see this. So this one, And so here, if you in the middle top, so the root openings, depths, plug or filling, depths of the filling for plug and slot welds. Okay, so depths of the welding, and on top of this, the finishing symbol, and in a place. Okay, so the groove angle, you can write an angle, and in here you can add the depths of preparation, size of strings of certain welds, the size of weld. In here you can write an abbreviation of the process. Okay, so what kind of welding type. Okay, so type of the welding, and here the number of spots, like if you have in next slide we have actually, so you are welding here one plate, okay, spot, 3 spots, so you have to write number of spots of projection also, so here will be 3. And in L and P, so in L, length of the weld, and in P place the pitch. Okay, so the distance between these 2 spots. And okay, so this round means weld all around symbol. Okay, so this might be on a different side, it might be something like this also. It's no matter, same thing. Here the field weld symbol, and you can write the values. Okay, so all these values there. So here some example of spot, seam, flash, and upset welding symbols. So here, this one is the spot welding. So just in simply in the middle, the circle is shown in the middle. Okay. The seam welding is shown a circle with parallel lines, and this is a flash welding. And here you can see on the right hand side there is RSW and EBW is shown. RSW means resistance spot welding, and EBW means electron beam welding. So the required process of the welding. Okay, so it should be shown on the tail of the symbol. And the size of the welding, diameter shown with diameter in inches. We can show in millimeter. You have to write it there. And the strength of welding, and in the Newton, and the pitch of welds. So pitch of welds. So if you have 3 welds there, okay, the distance between this the weld spots, there is a 3 inches. So you have to write it here. And the number of welds can be shown with bracket like this way. And okay, so let's see what's a spot welding, seam welding, and flash welding. So here the spot welding is if you have pleats, and so here the like this lap joint, and we have welding here, welding the spots. Okay, put the points only welded here. That is a spot welding. The flash welding cross section is like this. Okay, so we are making the welding with some kind of flash. Okay, so and we have this kind of thing. And upset welding, we are welding and moving to this side. The first we are pressing with the pressure and then moving to another side, so we will have this kind of cross section. And after, okay, so the both things can be flattened after machining. It might be flat like this area. Okay, so and there is a flash welding, we need to write like this: if W, and offset welding represent, okay, can be represented like a UW. Okay, so here FW means the process. Okay, so flash welding, and if you have like this, so offset welding, and this area can be shown like this way. Okay, so concave or convex, and the reference. Okay, so finish to smooth contour, that means. And if you have like this, that is machine flash. Okay, so the do like, okay, machining it, so straight, make a straight. So it before it becomes like this, and after grinding or polishing, it will be like this. Okay, so the grinding, and here we can see flash and offset welding, and also offset welding, sometimes it calls butt welding. So in left hand side, yeah, the process, the flash welding process is shown. The two parts, which is the is going to weld that part. From one side is fixed, and a second clamp is movable, and the right hand side clamp is stationary, is fixed. And we are using AC power for this, and using this AC power, we are making the arc in the touching together or welding place comes with arc. Okay, so that is a flash welding. So the kind of flashing in the touching place. And in second thing, okay, so second welding type is offset welding or butt welding. So the shortly we're using abbreviation UW. In this place, so welding place, there are no flash, no arc. Okay, so only the heat is used for this one, and also we are using a force here. Okay, but here in the flash welding there are no force, no force here, no force here. In offset welding, same thing. Okay, so from here is fixed, from here is fixed, but from here that is movable, so like this thing. Okay, so from here that is fixed, but here we have a force. Okay, so we also use a AC power supply, and okay, so that will be welded. So we are having a welded place like this. Okay, so next one. That's the main difference between the flash welding and offset welding. Seam welding and spot welding. In the seam welding, actually we have a contact with contact with wheel. Okay, so contact is appearing between the wheel and welded metal sheets. So metal sheets are given here and here. So so wheels are rotating here like this way, and in here touching area to the metal sheets appearing kind of energy. So and so that energy will go to in between the two sheets of the metal. So we are using AC power to create an energy, and that will be welded. Okay, so we are moving to this side, or that will be rotated and making kind of welding seam. Okay, so seam welding. And on right hand side, the spot welding example is shown. So this is welded part 1 and part number 2, and that is also sheet. Actually we're using this one for thin plates or thin sheets,
to weld. So we are making kind of dots with using a AC power supply, and also using a force here from both sides is punching that two sheets and then making a point, so dots. So that's what we call a spot welding. Okay, so resistance spot welding. Fillet welds. Okay, so here the example of the fillet welds are shown with in real life. So legs is 0.5 inch and 0.5 inch here, this and that. And in the drawing we are using kind of tag, and in the we also use here a triangle shape, and here we can write the length of the leg, because of the legs are both legs are similar, so we have only one size. If you have a different leg like this, so the shorter and longer, so we can write it here like this way, and in the bracket, inside the bracket. And this, if you have in both sides, okay, so this one is in the bottom, okay, so bottom means this side, right hand side. If you have on the top, please, same sizes, that means the joint, like in the both side, will be welded. Okay, so and the size of the leg is this, both side, and there are two numbers are shown. The first number shows this value. Okay, so the length of the welding weld, length of the weld, and the second number represents the pitch of the welds. Okay, so the pitch, okay, so distance between two welds. And if you have like this way of showing the welds, that means the one side weld leg is smaller, another side is bigger, and the length of the weld also, the another one side here, okay, so this side, the length of the weld is bigger and the length of the weld is smaller, so this value, this, instead of 2. Okay, so as I told you before, so if you have different legs, one leg is bigger and one is smaller, so it shows like this way. So first comes smaller size and then bigger size, so this horizontal size and then vertical size. Then if you have symmetric weld from both side T-weld, T-joint, like this symmetric, so we have same like this top side and bottom side, some are same, like 2 minus 5, 2 minus 5. And if we have non-symmetric, something like this, so here one weld and another weld, the distance in between is 10, but another side in the middle of these two, and then also it has a same pitch, okay, so same, like it might be 10, so that will be distance is like this. Okay, so it will be upper side and lower side is not symmetric. It shows non-symmetricity with this way. Okay, so this comes first, and then there's indentation in the drawing of the triangles. Okay, so distance are different. So first shows the size. So size, the length of, okay, size of weld or length of the weld are same. So that's why 3 and 3, and distance, okay, of the two welds are same. Okay, so 10, and here is also 10, so that's why there is a 10, 10. But only thing is the legs also same. So the only thing is this one, triangles, one is comes first, and then second is small later on. Okay, so that is an indentation. So this one shows the bottom one, and this one shows the upper one. Sorry, so this one shows the first comes is bottom one, and the okay, the top one, okay, top one is shows this one, okay, so this, and bottom shows this one, okay. Okay, so the next, so here we can have different type of welds, okay. So groove welds are shown in the reality, so but in the drawing it will be like this, simplified, okay. So here the angle, and then so 60 is here shown, and distance between two pleats are shown here, and the depth of the penetration is shown here. That's a key weld, and that's a U shape weld, and here the triangular again, okay. So and then two side welded like this way, can be represented like this way. So in the ghost also similar, okay, the meaning are same principles, same characteristics, same terminology, but there is a minor differences we have in the ANSI and American Standard. In ISO there is a for welding we are using in the arrow, okay. So like this arrow, two-sided, but in our case we have one-sided arrow, okay. So in the ghost we're using only one side arrow, or something like only one side is shown, there are no another side, okay. So only one side. And also that the spot weld have just only like this points, so this means two plates are welded in these points, and so here a spot weld, okay, shown like this way. And that is a seam weld, so this plates should be welded, seam weld. So the SL line, okay, so it should be welded with this way, so yes, with this way, okay. So seam weld, that's the spot weld, the right hand side one. Okay, so there is a, in the ghost we are having a tag, writing the label like the words, okay. Ghost, then a number, so number represents, this is a standard, okay. So ghost number, and then a year also represents that the ghost is approved, okay. So is taken into the using, okay. So and there is a some values, okay. So after this, so in next slides I will show what's the meaning of this. And this one is a size, okay. And here we can see the different type of representation. So triangle is a fillet weld, and the size of this, another value. One leg is this one, and a different size leg. And also this kind of symbol, this symbol means is not closed thing, but all around, all around except one side. Okay, so this side and that side should be welded, the meaning. So another side is opened shape. So on next slide I would like to show. So another symbol, please see this kind of thing, just make attention. So this kind of symbol, I will show on next slide what's the meaning. And okay, so all yeah, this one, that means all around. Okay, so this side and this side should be welded. So here the meaning of the symbols are shown. Similar to the ANSI, we have like this big circle, that means all around sign. And in ANSI we have this kind of flag, okay, flag, or like this flag. But here in the Ghost we don't have a flag, but we have like this symbol, small, like this line with corner, okay, 90 degree. So that is a that means field weld symbol. Okay, and second thing comes, okay, so here the name, okay, the Ghost, okay, word of the Ghost, then the standard name, and then the number of the Ghost. Okay, so this is a year, the document approved. And here the third level, okay, so what will be next? Designation of the seam. So there is a number, okay, the values, okay, with a character and then value, okay, so number, H1, T1. So I will show what's the types of the designation of the seam type, and how to understand what's which one. Okay, so and then after this comes welding method. So this one, welding method, it's not mandatory to shown. You can do not you might not use this one, but the next one you can use. Next one is triangle symbol, means the leg size of fillet weld. Okay, so if you have a fillet weld, so the fillet leg, a triangle leg, you have to write it there. And next of this, for interrupted seam, so we have this kind of slash or the Z sign, and you can write the pitch size of this. As I told you, the last came pitch size. Okay, so and the 7 position, the latest one, and the additional symbols can use on right hand side. So here is shown what's the meaning of them. So this means grind after welding. So you have to weld it. After this one you have to grind it and polish it. Okay, so you have to make it straight. So the welded area, you have to make it straight. So this kind of symbol means top of the seam should machined with a smooth transition to the base. Okay, so you have to be careful when you're grinding, and when you just about to the just to get the size of the original size, so you need to make a slowly transition. Okay, so you have to slow down and be careful with the top of the plate. Okay, so but here this one is different, so just you can grind it, but here you can grind, but you have to be careful and when you near to get to achieve the top side of the part, okay, original part. And this one is opened contour seam. So and if you have this one, so like all around symbol, so everything around you have to make it welded. Okay, so closed contour seam. Field welding, same like in the Ghost, in the ANSI. And the continuous position spot welds. Okay, so if you the positions of the spot are similar, so you can have this. If you have like this weld, okay, so different pattern or different okay, zigzag pattern kind of thing, so that you can write it like the zigzag, okay, zigzag pattern position spot weld. So we'll see in examples. Okay, so and the cost numbers, what's this this thing, so there's a types. This cost is manual arc welding, okay, and this cost is about submerged welding. So if you have this one, automatic and semi-automatic submerged arc welding. This one is gas carbon arc welding. This is just arc welding. This one is arc welding of aluminum and aluminum alloys in inert gases. So you need to special condition to make a welding. So because aluminum should be welded in special place with special gas there. And electro slag welding, contact welding, and this one is welded joints made of polyethylene, polypropylene, and vinyl plastic. And this one is gas shielded arc welding. This one is electrical contact welding. So here this one is Russian words, Russian description, okay, so of this course. So here the symbols, as I told you, there is a capital letter and then the symbol. What's the meaning of this? So that means the type of the weldings. Here the welding should be, you know, so these sides should be welded. And what's the meaning of this? Each one means here, this one. So here the upper side welding, so two side welding, and one plate is like this section like this way, okay, and that's the plates are made like this way, and that's the fillet weld again. So here you can see the difference, Y4 and Y5 here. And this one you can see the T-joint. So another T-joint, one-sided and double-sided T-joint welded. And here the plates are welded, should be welded like this way. And here you can see from two sides you have to weld it. You have to weld it from two sides. Another type of the joining is joining with rivets. That is we are using this type of the joints for non-metallic part joining, and also where thin plates joining can be done with rivets. Okay, rivets are used to hold sheet metal or rolled steel together as permanent fastenings. And here you can see the different types of riveting. Single riveted lap joint, so lap joint with single line, and double riveted lap joint, so two lines like this, and single riveted butt joint. So this is a butt joint because we have here one more. Okay, so this is one plate, another sheet metal. So but here we have a upper package here, so another package here, another sheet, so and then two layer like this. And double riveted butt joint, so here each side has double raise like this. And here on the bottom you can see the types of the rivets. So the button head, so based on the head we can differ the types of the rivets. So high button head and cone head pan head, so yeah, because it looks like a pan, the bread pan, and flat top and round top countersink head. So at the top you can see a little bit convex. Okay, so another type of connection is glued connections. So this is by Gauss. We are using this kind of representation style. So glued connections are used to create permanent joint also of metal or non-metal parts. So in here, same like riveting, we can use non-metal part joining, but welding can be used only for metal one. Okay, non-metal one we cannot use for weld. Okay, welding cannot join together, but riveting can join, and glued connection, glued method can join together. So the place which is joining can shown like this way. Okay, so this kind of symbol, the arrow, and then this symbol means a glue. So this area is kind of glass here, that is metallic part, so here should be glued like this way. And the round shape is shown here, and this area is glued. Okay, so all around like this glued, and this is also all around this part should be glued. Okay, so so top of this sheet is glued with this shape, and then on the top of this is inserted, okay, this pleat. So another connections are shown in this slide, the spline connections. So spline connections are used to permit relative axial motion between the shaft and the hub of the connected member. Okay, so this is a shaft. Okay, so this is a shaft, and that is a hub. Okay, so with a hole, and the splines are keys made integral with the shaft and usually consist of 4, 6, or 10 in number. So when we use this one, when we would like to during the motion, we'd like to transfer the motion between to the another part, we are using this kind of connections. Okay, spline connection during the motion, during the, for example, in the car transmission or car gearboxes inside. So during the motion of the car, so we'd like to transfer the motion, rotation, to the another part, and sometimes we'd like to disconnect this motion. Okay, stop this motion transferring. So then we're using this kind of spline connections. So this way, to transferring ways are shown here. So we can insert a shaft into the hub, and then we can use this kind of set screw in this hole. So make a hole to the both parts and then insert it, screw in, and so then you can do. And then, but to disconnect this one, you need to take out this. Okay, so then you can disconnect it, or you can use a pin. Make a hole and insert a pin inside of this, and then you can rotate it, so that will rotate also. But to open this, you need to take out this, so that takes a time. And you can use a keyway, so insert this keyway. But the spline shaft said during the motion you can insert it to the hub, and then if you go to this direction, so rotation stops. Okay, so that can be two types. One is internal and external teeth. So external teeth is this one, internal one is this one. Okay, so that's external, that is internal. So that can be 4, 6, or 10 teeth might be. Okay, so that's it. So this is end of the our lesson and our the class. Okay, thank you very much. So if you have any question about the class, please send me by email. So thank you very much. Thank you for your attention.